This is the video for station number 4, where we're going to work on the last part. Is sometimes you work with a fraction and a radical, and no matter what you do, you can't simplify it and get the radical out of the denominator. But the rule is there can be no radicals in the denominator of a fraction. So our last resort, if we can't use simplified fractions or it's not a perfect square already, is to do this rationalizing process. If there's a radical in the denominator, I can multiply a fraction by a form of 1 or divide it by a form of 1, treating the numerator and the denominator exactly the same. So if I rationalize the denominator by multiplying it by another factor of itself, in this case another factor of the square root of 3, then I will work with what has happened to this. So in the denominator I get square root of 9. In the numerator I have a non-square root, I have a whole number multiplied by a radical, so those just hang out near each other. I do know the square root of 9, and the square root of 9 is the whole number 3. So I can replace the denominator. Then the only thing I would check, and in this case is not a problem, is if 5/3, that outside fraction, could be simplified. If it could, I would simplify that outside fraction but leave that square root of 3. In the next example, first if I go to take the square root of both parts, I'm going to get a radical in the denominator. So if I find myself in that position, I know that the numerator is the whole number 2, but that denominator with the square root of 5 cannot be left that way. It would break the rule. So again, that rationalizing process is to multiply it by a factor of itself, keeping in mind that then the numerator will have to get multiplied by that exact factor. So in our case, we're going to have 2 square roots of 5 in the numerator. The square root of 5 times 5 are 25 in the denominator. So then as I go to work with this, my numerator can have a radical, that's fine. My denominator becomes the whole number 5. If 2/5 could be simplified, I would. In this case, it already is.